Hi everyone, let's give this geometry problem a try. Prove that in any triangle ABC, the area of triangle ABC is equal to lowercase abc divided by 4r. So before you give it a try, let me establish the notation. So I'm going to draw a triangle, and we'll use capital letters to denote the vertices or the angles. And we'll use corresponding lowercase letters for the sides opposite the angles. So that's pretty traditional notation. And then, as I said, the parentheses surrounding the name of the triangle is referring to the area of the triangle. And then one more thing, we have a capital R in the formula. That's referring to the circumradius, which means the radius of the circle that circumscribes the triangle, or in other words, passes through the three vertices of the triangle. Okay, so now that we've established the notation, go ahead and pause the video and give this problem a try. Okay, in order to prove this particular area formula for the triangle, I'm going to begin by drawing an altitude and using the standard textbook definition of area, or standard area formula. I'll call that altitude h, and we'll say the area of ABC is equal to 1/2 BH, so 1/2 base times height. However, I can use right triangle trigonometry to say that the sine of angle A is equal to h over c, which implies that h is equal to c times the sine of angle A. And I can substitute that into my area formula, and I have the area of triangle ABC is 1/2 BC sine of A. Now that formula is pretty famous. You may already know it. It's saying that the area of a triangle is 1/2 times the product of two of the sides times the sine of the angle between the two sides. And you can write a similar formula from the point of view of any of the vertices. So this formula is going to be our starting point. And there's a sine of A in the formula. And what we're headed for is ABC divided by 4R. And if you recall from my previous video, the extended law of sines relates the sines of the angles to this circumradius. So we're going to continue to work on this problem by utilizing that extended law of sines. Okay, so by the extended law of sines, we know that lowercase a over the sine of A is equal to 2 times that circumradius. Okay, well that implies that the sine of A is equal to lowercase a over 2 times r. Well, I can substitute that into our area formula at the top of the screen now. And I come up with the area of ABC is 1/2 BC times, and I substitute a over 2r for the sine of A. And that can be written as lowercase abc over 4r, and that's what we were supposed to prove. So it seems we've proved it. Just one more detail though. Going back, when I drew the triangle, I was assuming that this altitude was inside of the triangle. Well, let's consider the case where angle A is obtuse, like this, which causes that height to be outside of the triangle. Well, let me call this acute angle here alpha. And so alpha and angle A in the triangle are supplementary. They add up to 180 degrees. Well, we know that the sine of alpha is h over c, where c again is this side opposite the capital C. But we also know that the sine of alpha is equal to the sine of its supplement. Two supplementary angles have the same sine. For example, 60 degrees and 120 degrees both have a sine of square root of 3 over 2. So that means that the sine of A is h over c in this case as well, just like we see over here on the left when A was acute. So it doesn't really matter whether it's acute or obtuse, you can still derive this same formula. The area of a triangle, any type of triangle, is equal to 1/2 times the product of two sides times the sine of the angle between them. Okay, so that completes the proof. Thanks for watching the video.